Good evening, Dad here from Dad Teaches. Today is not so much a teaching thing as much as it is a just a demonstration of what's going on here. So I've heard a lot about this home PCR test, and I'm just curious. I was curious about it. You know, a lot of people say it has dangerous ingredients in it and so forth. So I wanted to kind of check this out. I'd rather check information out for myself and do some research on it than just hear what's going on. People say it has deadly agents in it or whatnot for this home PCR test. Well, if you see, do not open until instructed to do so. This is coming from the fda.gov/media/147260/download, and then you get this PDF download of this. So you'll see the link here. And then it says this home test is for FDA emergency use authorization only. Well, if you've read anything about this emergency use authorization, they're kind of using everybody as guinea pigs. But my point wasn't so much about this, because I've heard of this test and any other PCR test and yada yada yada. Has a very high probability of false positives. If you know what a false positive is, like in the information security world, it means that something is flagging as a vulnerability when it doesn't actually exist. It might be like an old zipped up file or something or an old binary or executable that's not installed. It's just an old binary or executable, but your Nessus scanner or something will flag that and say, hey, it's installed your vulnerability, it's a critical finding, when honestly it's just an old binary, right? You delete it just to clear up the finding, but it doesn't really add any vulnerability to your computer. Somebody has to still gain access, administrative controls. Anyways, beyond that, false positives for the PCR test. So I didn't want to go down here. It says potential risks include potential or possible discomfort and possible incorrect test results. So it's like, okay. Now, this is just on like page 3, and I hadn't gone too far with that. It says hazardous ingredients for the reagent solution, and it says this sodium azide, and then whatever this CAS is. I don't know what that CAS is, what that means. So I'm not a chemist or anything like that. So, and then going through that, I read a little bit over it, but I was looking for anything that in this pamphlet should be labeled as like toxic, hazardous, or whatnot. So you find it. Wash your hands. Make sure everything is dry before starting. I'll get to that why you make sure everything is dry before starting. Granted, when you take the PCR test up in your nostrils, probably not dry, right? Instructions on how to do all of this. Open swab. Swab the nostrils. 5 to 15 seconds. That's a pretty good long contact time, right? I mean, you could do a like a skin scrape biopsy with much less contact time. So, curious as to why you're supposed to do this so much, but I'll let you make your own conclusions. But anyways, the rest of this is just instructions. It looks like a home pregnancy test, but you're not pregnant. You're pregnant with COVID, and tells you. Yada yada yada, but I didn't see any other information in here that led to any of the toxicity or anything like that. So we'll go all the way back to the top, and I'll look at this sodium azide. So I went to the CDC. So this is emergency.cdc.gov/agent/sodium azide/basics/facts.asp. Let's look at this. Let me make this a little bigger for the camera so you can see that. What is a sodium azide? A rapidly active, potentially deadly chemical that exists as an odorless white agent. When mixed with water or an acid, water being even the stuff in your nostrils, sodium azide changes rapidly to a toxic gas with a pungent, sharp odor. It also changes into a toxic gas. Hydroxylic acid, when it comes in contact with solid metals. For example, when it's poured into a drain pipe containing lead or copper. The odor of the gas may not be sharp enough, however, to give people sufficient warning of the danger. Whereas sodium azide is found and how it is used, it is best known as a chemical found in automotive or automobile airbags. An electrical charge triggered by an automobile causes sodium azide to explode and convert to nitrogen gas inside the airbag. All right, so it's a simple explosion conversion, or what we call like an oxidation. Sodium azide is used as a chemical preservative in hospitals and laboratories. Accidents have occurred in these settings. In one case, sodium azide was poured into the drain where it exploded and the toxic gas was inhaled. Sodium azide is used in agriculture for pest control. Sodium azide is used in detonators and other explosives. All right, well, sodium by itself is used because sodium reacts, has a very fast and harsh reaction. It oxidizes very quickly when you put it in water. So as sodium batteries, the Army used to use sodium and lithium. Well, lithium does the same thing too, but the sodium and lithium batteries, you can cut them open, make improvised explosives out of them. More of kind of noisemakers, not like frags or anything like that. But how could you tell if you're exposed to the sodium azide? Following a release of sodium azide in water, you could be exposed to it by drinking the contaminated water. Following contamination of food with sodium azide, you could be exposed to it by eating the contaminated food. So, okay, that's kind of obvious. Into the air, you can be exposed by breathing the dust or the gas that is formed. It can enter the body and cause symptoms through skin contact, which you're 5 to 15 seconds of skin contact in each nostril, you know. An explosion involving this can cause burn injury. It's an explosion of any chemical, I think, could cause burn injury. And chemical and toxic gas, hydroxylic acid. How sodium azide works. The seriousness of poisoning caused by sodium azide depends on the amount, route, and length of time of exposure, as well as the age and pre-existing medical conditions of the person. Breathing the gas that is formed from sodium azide causes the most harm. I mean, you're putting it straight into the top of your nostrils, but ingesting it can also do that. And remember, you can ingest it. Say if you're mucousy and whatnot, you mix that in, you're swallowing mucus all the time from your nasal passages. The gas formed from this is dangerous in enclosed places where the gas will be trapped. The toxic gas quickly disperses in open spaces, making it less harmful outdoors. The gas formed is less dense, lighter than air, so it will rise. So it's kind of, you know, it's not the best if this happens to react and make gases in your nostrils, I guess, that is going to rise into your sinuses. So, this prevents the cells of your body from using oxygen. When that happens, the cells die. That's kind of a hypoxic, making a hypoxia, you know. You're breathing in too much carbon dioxide or some other gas and not enough oxygen. Sodium azide is more harmful to the heart and to the brain than other organs because the heart and the brain use a lot of oxygen. Immediate signs and symptoms of this. Okay, so it's going through clear drainage of the nose, cough, dizziness, headache, nausea, and vomiting. Rapid breathing, rapid heart rate, redness of the eyes, restlessness, weakness, and skin burns and blisters. So that, I would think that might be quite a bit, but at the same time, it's like some of these things, you know, are also like signs and symptoms of COVID. So I don't know. Exposure to large amounts of sodium azide by any route may cause the following health effects: convulsions, low blood pressure, loss of consciousness, probably from low blood pressure, lung injury, respiratory failure during death, and slow heart rate. Showing signs and symptoms does not necessarily mean that a person has been exposed. No, that's very true. What is the long-term health effects that may be? Survivors of serious sodium azide poisoning may have heart and brain damage. Now, what I haven't found in here, maybe we'll look at that, is the toxicity of this. Because if we go back to this sheet, this concentration is 0.0125. So I'm assuming that some of these things are talking about like dumping a gallon of this down the sink. But so let's find out. I'm going to go ahead and Google this right here. We'll just do this. Toxicity. That's the same page, toxicity seminary. This is the nih.gov. Let's see if that's in there. We'll go to stanford.edu. No toxicity. So I already see some CDC emergency response card. So let's go to the CDC one first. We'll drag that one over. Systemic agent, colorless description. We got a lot of that earlier. What I'm looking for specifically is what levels is toxic. Oh, that's what I wanted to point out too. This CDC fun facts, the fun facts. Was it the fun facts? Yeah, right here. If you're exposed, if you've ever been in the military, you have something called MOP, Mission Oriented Protective Posture, and that's your gear that you use for a CBRN environment. So it's chemical, biological, radiological, and nuclear CBRN. So you have that big suit. It's called the MOP suit. Your mask, head coverings, glove, boots, yada yada yada. And when you decontaminate, there's a whole series of decontamination. You have to come through a dirty site, go through the decontamination process, come out butt naked the other side, and hopefully you're clean. Not necessarily butt naked, but don't underestimate how many times you may be naked in the military. All right, emergency response, chemical dangers. We've got that firefighting information. What I'm looking for here on this is short-term, less than 8 hours exposure. Sodium azide is a broad spectrum metabolic poison that interferes with the body's ability to use oxygen to support life. So that's kind of weird. The most commonly reported health effect is low blood pressure, hypotension, which goes through all routes: eye exposure and inhalation, skin contact, eating, drinking, decontamination, first aid, long-term implications. On-site facilities. What I'm looking for, okay, occupational exposure limits. So I'm not sure what, I'm guessing the EL is exposure limit, so I'm not sure what the NEOSH-R is. Ceiling is 1 part per million, or that ceiling is 3 milligrams for skin contact. So 0.3, let's go back to this is a 0.125. So that's significantly less than your toxicity part for skin contact. But either way, all right. I don't know. The OSHA didn't say anything, but they'll enforce the laws. TVL, TLV, anyways, this is 11 parts per million or 0.29 milligrams, which is pretty much the same as that. This is all 0.29 milligrams. And not established. Exposure 5 minutes. So they don't have any not established or determined. I'm not sure what the acute exposure is. You might be dead by then. Here's your chemical properties. So there's nitrogen 3, sodium, nitrogen 3. Melting point, melts in explosions. That's probably where you get the nitrogen gas, N3, with the explosion that decomposes the sodium part of that. So this shipping name, it definitely has a hazardous warning placard. All right, so that gives us a little bit. So 0.3 milligram, 0.29 milligrams per meters cubed. Let's see if we can find something in this. This is the National Laboratory of Medicine. Oh, this. Death occurs rapidly when doses are absorbed, either due to the direct effect of sodium azide or an indirect effect during nitrous oxide, cyanide ions, or hydroxide acid production from sodium azide. So the minimum hypertensive exposure lies between 0.2 and 0.4 UG per kilogram. I don't know these well enough to do the math off my top of my head. I don't know the unit UG. I don't know if that's milligrams per kilogram, but still that's lower than the 0.29. Where was that at? I think that was up here, or was it down here? Established guidelines. So this is kind of an aerosol version, 0.3 milligrams per meter cubed, so that's a cubic meter, 0.3 milligrams. But this one is looking like it's measuring 0.2 to 0.4. I think UG is milligrams per kilogram. UG, what were we thinking of? Were units? UG, kg. Okay, convert UG to kg. Okay, UG, micrograms. So that is micrograms to kilograms, so 0.2 micrograms. So what we have to figure out here, let's do this. Okay, that's 0.125% is of the ingredient base, but I don't have the full ingredients here to figure out and what the rate is. So we'll just kind of go with, I mean, it's really kind of hard to figure out whether or not, because I don't have a full, that's got hazardous ingredients, but it doesn't have a full ingredients list, nor does it have some other telemetry I'd be looking for. Okay, inhibits respiratory and bovine cornea. So it's definitely showed that if you have injection in rats, result in severe intoxication. Well, really. Sterility produced in male mice given indicate Sodium azide has a potential mutagen in salmon sperm DNA in an acidic environment. What's an acidic environment? Well, a woman. And I'm not saying that other than the fact that I do believe that a female vagina is slightly acidic. And that it's slightly acidic in order to kind of kill off the weak sperm. So, interesting, I suppose. And this is going from the stanford.edu site. Let's go ahead and take a look at this. Same formula, sodium, nitrogen 3. Toxicity level, LD50 oral, 27 milligrams per kilogram. So that's really high compared to the other ones per kilogram. So as we saw on this one here, that, I think it was this one here, that's meter cube, so that's kind of like an aerosol version. So this is milligrams per cubic inch or cubic meter as well. But we also see that, occupational exposure limits from the CDC site here is really low. But at the same time, I'm not going to pretend I'm smart enough to know that. Here it says the same thing, 29 milligrams per cubic meter. That's the ceiling, so that's the high side. Now, if you can imagine the top of your sinus cavity is much less than a cubic meter, is probably closer to like a cubic centimeter maybe at the most, but cubic half centimeter. So that toxicity might increasingly raise, especially with however much is used on this swab here, which is whatever that concentration is, but you have to find out what that is per weight. Alright, key toxicity is high. Exposure includes lower blood pressure, headache, hypothermia, and in the case of severe overexposure, convulsions and death. Ingestion of 100 to 200 milligrams in humans, which I think is way more, may result in headache, respiratory distress, and diarrhea. Target organs are primarily the central nervous system and the brain. Sodium azide rapidly hydrolyzes in water to form hydroxyic acid, a highly toxic gas that can escape from solution, presenting a serious inhalation hazard. And I think because it is an acid, an aerosol acid, it's going to affect your soft tissues, especially within your lungs and your nasal passages and so forth. Symptoms of acute exposure to this acid is eye irritation, headache, a dramatic decrease in blood pressure, weakness, pulmonary edema, and collapse. Solutions can be absorbed through the skin. Has not been found to be a carcinogenic, and it's non-cancer causing in humans. And it doesn't matter if it causes cancer because it seems like it could potentially kill you. So, especially hitting these falling low blood pressure symptoms. That's not. I mean, you start hitting falling blood pressure symptoms like that when you start having heart problems, and they actually give you a lot of drugs to stimulate your blood pressure to get back up so you don't have a heart collapse. I don't care about the flammability. I mean, we already know it can decompose in 525 or apparently 275 degrees Celsius. And they should not be allowed to come in contact with heavy metals or other salts. Well, we have salts in our body, and especially in our snot, our mucus. If you've ever had that snot drip down your mouth in the middle of the wintertime, it's definitely salty. So, and salts, NaCl, hydrochloric acid, or not hydrochloric acid, that's your sodium chloride, which is your regular table salt, also resides in your body, and those are metals. Sodium is a metal. Chloride is not a metal, but so I don't expect one of these nasal swabs to make your sinuses explode. But when people are saying that it is, I mean, you go through like a hazmat scenario here when you're disposing of it. So. And you're reacted to a lot of it. So 27 milligrams per kilogram for a rat and 20 milligrams per kilogram per person, or for that, 0.29 milligrams per cubic meter, high toxicity, and I think there was something else in here. So, at the same time, I do believe that even though that this concentration at 0.01.25% is probably too low. It's probably too low on the mass of a human scale, but at the same time we're concentrating that into one very small region of your body, which is the top of your nasal passage. Or not the top of your nasal passage. Yeah, it would be the nasal passage, and it goes into your sinus. But I want to take a look at that because I've heard a lot about this. The past few weeks of PCR tests are dangerous, and they have dangerous chemicals and so forth. So I wanted to look at this a little bit. It does have dangerous chemicals, and I would really like to understand why they would feel the need to put something like this and something that definitely can cause an acid, cause respiratory problems, heart problems, brain problems, and hypoxic conditions based on this, especially when you talk about a lot of people that go to the hospital and start suffering these conditions. I'm not saying the PCR test does that by any means. However, this it's just interesting. I don't know. I'll let you make your own decisions on this. I don't know the math behind this. I'd have to sit down and figure out the units and so forth, and then I also figure out how much that 0.1.2 or 0.0125%, so I think it's about an eighth of that, and how that would affect anything. But I can only imagine people that maybe test twice a week, or every time you're supposed to test every day before work, or twice a week, and just imagine that you could this could potentially lead to a toxic reaction in the body. When they're saying, well, you have to get, your vaccines, or you have to test on this every single day. I can see where that would lead to a potential, like kind of like a heavy metal toxicity buildup in the body. And this right here is actually be reintroducing a gas that is known to create a hypoxic situation and so forth. So anyways, that's all assumptions on my part. I don't know the math behind it. I could find the math out right now, but I didn't want to do this on the video because it's already gone on for 25 minutes. Anyways, If you have any comments, questions, or concerns below, please leave them in the comments below. This wasn't exactly meant for kids, but at the same time, I do want the kids to realize that don't believe what you hear without some research and come to your own conclusions. That's what I'm ultimately saying here. As there's a lot of people, it's completely safe and there's nothing wrong. And I believe nothing when it's on the edges, right? When it's all or nothing, I have a tendency of ignoring those because I look at the edge of the bell curve, right? And these edges right here, I'm like, well, chop those off and let's get closer to the median and what that means. So, however, I mean, I think this right here, if somebody's a little bit smarter in the units used and so forth, should do a follow-up on this and not me. And I'd like to see somebody with some credibility. Granted, I have no credibility in any of this either. I just know how to read and kind of do some quick math in my head. But I can definitely see where the concerns are at. You do your own research. You find out what you want or don't. And either way, whatever you do, everybody has to always live with the decisions that we make. Have a great day, and until next time.